Welcome to another episode of Construction and Quality Control. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic in the construction, that is fiber reinforced concrete. Nowadays, it is widely used in the construction, but what is fiber reinforcement concrete? What is fiber? And what is the code recommendation to use the fiber reinforced concrete and where it can be used? So in this video, I will discuss each and everything about the fiber reinforced concrete. So stay tuned until the end to get the full information about this. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So, without wasting time, let's jump into the subject. That is our topics today's fiber reinforced concrete. That means the concrete with the fiber. Now, first we need to know what is the fiber reinforced concrete. FRC or the fiber reinforced concrete is concrete reinforcement with small uniformly dispersed fibers. Now, the fibers can be steel, can be glass, can be synthetic, can be natural. So, according to the requirement of the projects or according to the requirement of the structure, you need to finalize what fiber you want to use, whether it can be steel fiber, whether it can be polypropylene fiber, whether it's a glass fiber or is a natural fiber. So whenever we are introducing all these fiber in the concrete mix, it's become the fiber reinforced concrete. Now, why fiber are using? Why you are using fiber in the concrete? What is our purpose to use that one? That we need to know very carefully. The first thing is fiber are used in concrete to address the internal inherent limitations and enhance its overall performance. Concrete, while strong in compression and weak in tension. So we all know the concrete has the greater compressive strength, but whenever it is compared to tensile strength or the flexure strength, it is very much weaker. So if there is nothing there inside the concrete to withstand the tensile force, it will eventually. That is why we need to introduce something which is very good in tensile. That is why the fiber is introduced, as it has a tensile. Then and adding fiber improves the mechanical properties, durability and functionality specific. So that is why we are using. But why? Yeah, that is first is improve the tensile strength. That I already discussed, that the concrete, whenever we are using the fiber inside this, concrete is become more withstand the tensile forces, then reduces crackings. Now, it is a very common phenomenon in the concrete structure that after doing the concrete, there are different cracks is coming. So, may be the plastic shrinkage crack or it may be the drying shrinkage crack. Now, what is plastic shrinkage crack? What is drying shrinkage crack? I have made a detailed video on this. Link is there or in the description. Please check. You will get all the information about the different types of cracks in the concrete. So what is a plastic shrinkage crack? During the initial setting, water evaporate causes the volume changes leading to cracks. So during the initial stage, that is what it is in the plastic stage, these plastic shrinkage cracks is generating. And drying shrinkage, over time concrete shrinks when it loses water. So after the plasticity removed, when the concrete becomes strength gaining phase, or it react to the cement and the water, that time also reduces the water and volumes change and shrink, then again the crack is generating. To withstand that shrinkage and drying shrinkage or the plastic shrinkage, it is very much useful if we are using the fiber inside the concrete. It gives the enhancement of the tensile strength so that the cracks will not generated due to drying shrinkage or the plastic shrinkage. So then that it is increasing the durability. How? That is freeze thaw resistance. In cold climates, water inside the concrete freezes and expands, causing damage. Fibers help resist the cycle of enhancing concrete toughness. So what is freeze thaw cycle? How it is affecting the concrete and what is the best practice? I have made also a detailed video. Link is there or in the description. Please check. You will get the full information. So whenever we are adding fiber inside the concrete, it increases the durability, that it is preventing the freeze thaw cycle. Or during the freeze thaw cycle, what is the internal stress is generating, that is also arrested by this fiber. And abrasion and impact resistance, fibers provided additional energy absorption capacity, making concrete more resistant to wear and impact force. So it is in the industrial floor, there is a heavy equipment is moving, so there is the abrasion and wear and tear can happen. So in that case also it is very much useful to use fiber inside the concrete. Then enhance the ductility. Plain concrete is brittle. All we know that the concrete in nature is the brittle. So in order to increase the ductility, what we are it can be induce the fiber, so it will increase the ductility. Fibers increase the ductility of the concrete. This property is especially useful in seismic zones where structure experiences dynamic and repeated load. So in that case you need to increase the ductility, and to increase the ductility it is very much useful to add the fiber inside the concrete. Then improve the post cracking behavior. It is already we discussed that the cracks in the concrete is a headache. It's a nightmare for each and every engineer who are working on the site, because whatever you are taking the precaution, but generally cracks is appearing. So improve the post cracking behavior. That fiber also can be a very useful if we are using inside the concrete. Then to provide flexibility in design. Why? Because fibers allow for thinner section of concrete, reducing the overall material required without compromising the strength. If you are using the fiber, then it can be economical for the design. And then complex shapes and designs are easier to achieve using fiber reinforcement concrete, where maybe the complex shape we cannot use the reinforcement on that way. In that case the fiber is very much useful. And it is obviously whenever we are using fiber, that reduces the maintenance cost, because the maintenance cost is huge in concrete. So that is why it is very much useful if we are using fiber to reduce the concrete maintenance cost. So this about the fiber reinforcement. The next clause I will go, types of fiber. What are the types of fiber we can use inside the concrete? So first is we can use the steel fiber, that is high tensile strength and stiffens, commonly used in industrial floor and pavements. Another type of fiber is glass fiber, so lightweight and corrosion resistance, used in the architectural applications like facades and decorative items. The glass fiber, that is called GRC or GFC, whatever, the glass reinforced fiber concrete, GRFC. So that is used for the architectural element. Then synthetic fiber, especially polypropylene and nylon fibers, application used for plastic shrinkage control and crack resistance. So it is very much useful for the shrinkage crack when if you are using this synthetic fiber, that is polypropylene or nylon. Also we have something in the nature, that is natural fibers. We can also use that one also inside the concrete to reduce or improve the ductility and everything. That is jute, coconut coir and hemp fibers, eco-friendly, environment friendly and cost effective solution. So as per your requirement, what is the area of use, according to that you can choose the whatever, that is steel fibers, glass fibers, synthetic fibers and the natural fibers. So next clause will go the application of reinforcement, fiber reinforcement. Different area we are using, that is the industrial floor and pavements, tunnel lining and shotcrete applications, precast concrete products, hydraulic structures, slab and grade, marine and coastal structure. I will come this clause later. First I will check what is the design and construction guideline, because now we need to design the FRC or the fiber is for the concrete. So what is this proportioning of fibers, that these two things is very much important whenever we are dealing with the fiber reinforcement concrete, that is the volume percentage and aspect ratio. Compatibility, of course we have to compatible with the IS 456, ACI 544, or we have the IS 1026. So that criteria you have to final satisfy, but using the fiber. But here we need to know what is the volume percentage and the aspect ratio. See, volume percentage refers to the proportion of the fibers added to the concrete mix expressed as a percentage of the total volume of the composite material. That means fiber plus concrete volume to the total fiber. See, it is say why it is significance. This volume percentage typically ranges between 0.1 to 2%, not more than this. Beyond this range, workability issue may arise. Adding fibers improve mechanical properties already discussed, tensile strength, flexure strength, ductility, and impact resistance. So that is why it is very much important to know how much percentage of the fiber we can use inside the concrete. It is saying the volume ratio, volume percentage will be maximum 0.1 to 2%. It is, I will come to later, it is given in the code also. So this will be the, if more, then there will be workability issue, we cannot pour the concrete. Then another thing is aspect ratio. Aspect ratio is the ratio of the length of the fiber to the diameter. So it is expressed is the aspect length of the fiber divided by the diameter of the fiber. So what is the criteria why it is typical range? It is the aspect ratio usually varies from 20 to 100. That means length of fiber is divided by diameter of fiber is 20 to 100 to be the general. High aspect ratio provides better crack bridging ability, improve ductility, but low aspect ratio enhance workability but may have the limited impact on crack. So what is your requirement, what is your project specification? Accordingly you need to choose the volume percentage, you need to choose the aspect ratio also. So that is why it is very much important, you need to know whenever you are dealing with the FRC, that what is the volume percentage and what is the aspect ratio. So these two things it is need to be knew very well. Then what is the doses of fiber? See, in the IRC SV 46, it is given in clause 3.21 that FRC with higher flexure strength, shear strength, toughness and fatigue endurance, the better post cracking behavior is reduces the concrete polymer. See, here it is saying, see, SFRC or PSFRC, polymeric structural FRC, has been used in number of highway pavement, airport pavement, bridge crack fiber, that is 0.5 to 1.5 per volume, say 40 to 120 kg for steel fibers, and 4.5 to 14 kg per cubic meter for polypropylene fiber. So here it is given the clear guidelines of what will be the use. The mixed dose design of the same upper layer may prefer harder aggregates or smaller in size. FRC with or without adding silica fumes is also useful for the pavement. So in IRC SP 46, it is given in clause 3.2.1 that maximum will be 0.5 to 1.5% and 40 to 120 kg if it is a steel fiber, and if it is a polypropylene fiber 4.5 to 14 kgs. So whenever you are designing the FRC or the fiber reinforced concrete, you need to consider this, that what will be my doses and what is my volume percentage and what is my aspect ratio. Again in table 3 here given the fiber doses by volume fraction by equivalent doses in mix. See here it is given 0.1 to 2%, that I discussed, the maximum can be 0.1 to 0.2%. So if it is in steel fiber from 8 kg to 160 kgs, and if it is a polypropylene fiber 0.9 to 18 kgs. So it is given in table 3 in the same IRC SP 46. Check these two code to table and this clause, it is given clear guidelines what will be the maximum doses we can use in the concrete, in the fiber we can use, but according to your requirement you need to choose what will be the doses of your project. So these are the design and construction guidelines. In IRC SP 46 it's given how what will be the design criteria. If I will another video I'll make how to do the design for the FRC concrete, but in the IRC SP 46 it is given in details how you can design and how you can maintain that FRC concrete. So next is what is the relevant code that I already discussed, that is IS 456, IS 10262, and in ASTM C116, C116M, ACI 4544, and SP 46. Now we have some advantages and limitation of the FRC concrete. So what is the advantages? Already discussed, that improved durability, flexure strength, ductility and everything. But what is the limitation? The higher initial cost due to fibers, potential reduction in workability. So if we are using more fiber, it can reduces the workability, and if the workability is a concern, we cannot pour the concrete. So if that why you need to play accordingly what will be the maximum percentage of the doses of the fiber in the concrete, and also skill level is required. So you need to do more toward training and competency. It's a quality control part, training and competency, that you need to take care whenever you are dealing with the FRC concrete. So let's summarize what we discussed today. What is the fiber reinforcement concrete? What is the types of fiber used in concrete? Application of fiber reinforced concrete, design and construction guidelines, relevant codes, and advantages and limitations. So I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality and control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.